Okay, so this is going to be our 5th-hour discussion. We are trying to follow along, meet the success criteria that we can analyze and interpret data. So we are studying all this data from the change in mass lab. We're trying to figure out what errors may have been made. Does the data make sense? This is all the data, so if you didn't get a chance to copy it in class, it's all right here. And we're going to be going along station by station to talk about it. So we're going to start by talking about the wood splint station, and sharing their group's information is going to be Mimi. So Mimi, what did you guys say about the wood splint station? First of all, were there any numbers there that you thought were just way off? Okay. Is that what you think should have happened? Is it should have decreased? Okay. Does anybody disagree? Why do you guys think it should have decreased then? So if it decreased, what does that mean in terms of particles, number of particles? So we lost some, right? Okay, so what's your explanation for that according to what you saw at the station? Yeah. Okay, so just by looking at the data, majority of it showed a loss in mass. Anybody else want to add to that? Why they think maybe there should have been a loss in mass, or maybe you think it should have stayed the same, or maybe it should have gained? What do you think, Bree? Some of the ash kind of fell off of the wood splint. Did it fall onto the watch glass? Some of it did, some of it didn't. So would that be a good explanation for why some of the mass was lost? Seems like it. All right, so I'll just write this in here then, unless somebody wants to say something to disagree. We think some of the mass was lost. Okay. Station 2. And this is Daesan. Daesan. So we're talking about the melting ice. Talking about the melting ice station. So first of all, by looking at this data, do you think any of it was like crazy wrong, or was it all pretty good? The 0.8, lost 0.8, you thought that was bad? Okay. It is. It's kind of far off. What else about it? See, we've got some pluses, huh? Oops, not that one. What do you guys think should have happened at the melting ice station? What's that? It should have stayed the same, you think? Okay, so the same number of particles that we had at the beginning should be the same at the end for melting ice. Does anybody disagree with that? Condensation on, you notice condensation on the beaker? Okay, so what would that do to the mass? It would decrease it? Okay, any comments about that? If we saw condensation on the beaker, would the mass decrease? Any thoughts, any opinions? Mimi? So it's still on the object being measured. Okay. Anybody else want to say something? Does anybody else want to say something, maybe why the mass shouldn't stay the same? Because table 7 saying the mass should have stayed the same. All right. So I'll put mass same. Cool. All right, so station 3, what we did is took some steel wool. We pulled it apart, that's all. And so for this one, it is Bree Kinsey. Bree, what do you guys think about this data here, first of all? Is there anything that seems off? They're all pretty close. Nothing too bad. Okay, what is the trend we see here? What do you think? So according to the data, what's it look like happened at the station? Did we lose mass? Did it stay the same? Did we gain on the steel wool pull apart? So according to this, what's it look like? The data, like, does it look like we lost mass, stayed the same, gained? What do you think? Majority showed that we lost, okay? What do you guys think should have happened? Should have stayed the same, is that what you said? Should have lost, why? Okay, good observation. So they were saying it should have stayed the same, all you're doing is pulling it apart. But to be realistic, probably was going to decrease. Because when you were pulling it apart, you may have noticed, if you were the person that pulled it apart, you may have noticed that some of the steel wool kind of stuck to your fingers. Okay, so that would be particles lost. I'm going to say, just for the sake of pretending like we were real careful and it didn't, I'll put mass same. Okay, but that is error that we account for. Okay, some of it did stick to our fingers. Good job. In station 4, what we did was we burned the steel wool. And so to tell us about steel wool burning is going to be Seth. So Seth, did you guys get a chance to talk about steel wool burning? Maybe you guys want to help them out? First of all, if we look at this data, does any of it stick out as being way off? Or is it okay? This data, does it look like anything's way off, or is it all okay? Okay, it looks like it stayed the same. Should it have stayed the same, you guys think? What do you think? No? Who said no? Okay, why not? Because it's burning, so what's that mean? So what do you think should have happened, Mimi? So what do you think should have happened then? The mass should have went up or went down? Down? So we're losing particles? Does anybody disagree with that? Nobody disagrees? Does everybody agree with that? Same reasoning? Is it kind of like the wood splint one where you think the mass should have decreased? Mass lost, we lost particles. Okay, I'll put that down for now. All right, so let's move on to station 5. So station 5. Mimi, you might want to play the lottery today because your number just keeps getting rolled. It is 11. Cayenne. So Cayenne, you guys talked about sugar dissolving. What about these numbers? Looks like we got a pretty big range of numbers here. You think it should have went up when we, so I'll put that for now, mass gained. Okay. Did we have some different weird numbers, any kind of data that you think should have been taken out? The minus 97. Okay, so we have some big numbers in here, but at least on the positive side, they're all positive. So that one seems odd. Do you guys agree? Anybody disagree with that? Table 3, do you agree, disagree? That was your data, so I figured you might want to comment. What do you think maybe that they did wrong? What's that? No clue? Anybody have a clue what could have gone wrong there? Sugar being combined with water, dissolving it? Bree? Stirring, so we could have lost some while stirring. Some could have came out. Okay. Anybody else have ideas? Carol, what do you think? Any idea? If you had to guess? Davion? Any idea why they might have got that number? Lost 97 grams. That's a lot of particles to lose when we're combining sugar and water. Or is it that the sugar just disappeared? What's that? Didn't put in enough? Okay, they could have measured their masses and then not got all the sugar in there. Okay, good idea. I'll tell you, do you notice anything if we look at the first 4 stations, they were all kind of staying close together, weren't they? And now that we look at these last 4 stations, we're starting to see more of the big changes. And I think what happens here is, remember, like with the sugar and the water, we are taking the mass of the sugar, we are supposed to add that to the mass of the water. And that gives us our mass before. And I think what happens a lot of times is people forget to do that. So then when they compare it to the mass after, there's a big change. That could explain some of these other changes. In terms of particles, if we think about the particles, what does that mean? Like, what do you think should have happened? Sugar dissolving in water, what should have happened? Like, if I look at this, who did I call on for this one? Okay, like if I look at this cayenne, if it gained 40.95 grams, where did all those particles come from? What's that? From the sugar? But we accounted for all those particles. We measured that mass, right? We measured all those particles in mass. And then we measured the mass of the water. We added those numbers together. So really we should have the number of particles of sugar plus the number of particles of water, put them together. Any other ideas? Because these are showing that we gained a lot of particles. So if we if we gained a lot of particles, where did they come from? Gained almost 100 grams of particles there. Gained almost 41 grams here. Gained over 18 grams of particles. Like if we're modeling this, if we're showing the before, the during, the after, we got to account for where these extra particles came from, because if we're showing mass, wouldn't the last picture have more dots, more particles than the earlier picture? Wouldn't it? So where'd those particles come from? Just up here? So what are we saying for this one? Do you guys think it should have gained? You guys do? Okay. So I'll write that one down there. All right. And number 6. Dante, what'd you guys say about the baking soda and vinegar? Are there any weird numbers here that you think might be inaccurate? $149 you think should be taken out? Seems kind of off, doesn't it? Does anybody disagree? Thinks $149 should be in there? What happened at station 6, by the way, when we combined baking soda and vinegar? Bubbled all up. So what was in the bubbles? Anything? Air or something, some kind of gas, right? Is that matter? Is that particles? Okay, where'd it go? Okay, went into the air. So if it went into the air, what would you expect to happen to the mass on number 6? It should decrease, right? Because we're losing particles. So mass should be lost. So this is what I mean when we have our discussion thinking about what happened. Gaining mass doesn't seem like it should have done that. Okay? Lost some mass? Sure. Lost some mass? Sure. Lost mass? Sure. Those make sense when I think about what actually happened. So that's why it should have came up in your discussion when you're talking about it. Like, all right, it bubbled up, so we lost particles, so the mass should go down. What about with Alka-Seltzer and H2O? Think about what happened there and tell me about it. Lijuan, what'd you guys say for that? Okay, good answer, Lijuan. Scotty Powers. Scotty, what'd you guys say about the Alka-Seltzer and H2O? It should what? It should decrease. Why? There were gases leaving, right? Kind of the same thing as number 6. All right. So there again, we see some of the data showing mass gained. Where would it be coming from? Doesn't make sense. Doesn't make sense. This even seems kind of like a big loss. That's a lot of particles we lost. Okay. All right. And does anybody disagree with that? There were bubbles produced when we put the Alka-Seltzer in the H2O. All right, last station. John, what did you guys say about if we combine the calcium nitrate and the sodium carbonate? What do you think should have happened? No? Increase? Mass should increase? Why are you saying that? Because of the data? Okay, so we see some data showing increases. Thinking about what we did. Okay, so we had some calcium nitrate, we had some sodium carbonate, we added them together. What should have happened to the mass? Does anybody disagree with mass being gained? Leslie, what do you think? Should mass have been gained in this? Think so? How come? Two liquids mixing together, and they were making a precipitate, weren't they? Making a solid. Okay, so then where did those extra particles come from? Anybody want to tell me that? I assume you all agree because nobody's raising their hand to disagree. So where did the extra particles come from? Sean, any idea? So if we look at this station 8 where we combined the two liquids and we made a solid, we're seeing some gains in mass. Why would that be the case? How does that make sense? Where are those particles coming from? Davion? How? Oh, was it, you know? Who knows? How? Because what? Say that again. What did he say? But didn't we think about those particles first? Davion? Yeah, why would where's it gaining particles for? Why is it increasing? Or do you disagree that it shouldn't have increased? Okay, so the reaction, and then we got more particles. All right, so we're going to leave mass gained. There's no disagreements. All right, so what we're going to do tomorrow is we're going to start modeling these things, see if they make sense in our models. All right, so hang on to your stuff for tomorrow. Bring it with you, and we'll continue then.